moving to our next conversation, and there's some real themes and recurring interests and ways in which the conversation that you're talking about bridges exactly over to the work of Jenny Liang and Natalie Barrett. So I'll introduce both of our next speakers, and they'll take us from there. Jenny is an innovation expert, educator, scientist, focused on developing equitable emerging technologies. She is a founder of 4 Resolutions, a startup that develops aerospace applications for cities. As a chief innovation officer, board member, and secretary general of Sustento, an $8 million funded nonprofit serving frontline healthcare workers, Jenny developed and implemented healthcare services to a network of over 1,000 US free and charitable clinics with Uber Health and the CDC Foundation. Jenny taught innovation methodology to interdepartmental teams in Honolulu and in Providence, Rhode Island, as an innovation coach for Bloomberg Harvard City Leadership Initiative. Before that, Jenny wrote ethical guidelines and an engagement framework to generate games for 100 million Starbucks and United Airlines loyalty program members at the BCG-backed venture Formation AI. To inspire her work, Jenny teaches college classes in ethics and foresight as a way to develop accessible and innovative methodologies for emerging technology development. She holds a BS in plant biology from UC Berkeley and an MS in industrial design from Art Center. Welcome, Jenny. Jenny will be joined by Natalie Barrett. Natalie serves as a non-resident senior fellow at the Atlantic Council's Geotech Center and a Loomis Council member at the Stimson Center. While at the Johns Hopkins University Applied Physics Laboratory, she primarily focused on human-machine teams, artificial intelligence, advanced communications, and climate strategy. Prior to joining JHU, Johns Hopkins, she served across government and commercial industries focused on defense, innovation, robotics, and biotechnology. Key projects included wearables, exoskeletons, isothermal arrays that were realized in rapid COVID-19 diagnostic tests, as well as other innovations, a microarray reader system for Human Genome Project and cancer research. Jenny and Natalie represent the kind of collaboration between art, design, technology, engineering, science, and the big picture thinking that we hope you all leave this program with. So it's my pleasure to welcome them, and they'll take it from here.
Hello, everybody. It's such an honor to be here. I remember being a student sitting where you all are sitting here, so it's pretty thrilling to be here as a presenter. We are talking today about planetary empathy, sharing the potential of geospatial technology. And I'm Jenny Liang. I graduated here. I started as a product design student and then graduated out of the Grad ID program in 2008. And I've been doing innovation and technology development ever since.
And I'm an engineer who comes from 2 parents who are geologists. So they're super excited that I want to apply my engineering to climate.
So this is Natalie Barrett, and excuse me, both of us have had the great honor and privilege to be able to work on a number of emerging technologies and develop them and see and guide how they work. And today we're here because we're really excited about geospatial technology and satellite data. And what you have is satellite sensors either up in the sky or on the ground, and they collect data that's in the form of imagery or GPS coordinates. And people analyze this data to create information. And from this information, you get decisions. So these indicators or warnings tell you that it's time to preserve something, prevent something, protect something. So with this image, you might think, oh, geospatial technology, satellite data. Jenny's going to talk about stuff that's really for astronauts and NASA scientists. Probably not for me, but you would be wrong. Geospatial technology is in every one of your pockets right now. And you probably used it on your way here or are even using it right now. And so all of these and many, many more companies use geospatial technology And you should know that it has been designed already to be invisible and intuitive for us to use without even realizing the large space infrastructure that underlies it. So, for example, we all know and think about Google Maps. That's what we usually think of, but Instagram is also sending signals up to space when you tag where you ate lunch. Walmart and Target both use your location to figure out what the best item to sell you is, so you don't have to shop as much to find what you need. Walmart uses satellite data to find the best place to put their next Walmart, so you can have more convenient access to it. John Deere is looking at the land of the farmers that they sell to and using that data about their ground conditions to be able to sell them their next equipment. So we want to say this is not a niche technology. This is something that is everywhere in use by you right now. So today we want to talk about the potential of this technology, 2 problems that we see we think we should be talking about, and then a way forward to do that. So let's talk about the potential. So to understand the potential, you should know that we are in a critical inflection point when it comes to satellite data and geospatial technology. I'm just curious, give a thought to how many satellites you think are orbiting the Earth right now. How many? How many people know? Raise your hand. Angeli knows. She's clearly the smartest person in this room. You should know that too. And okay, how many people think it's like 100 or less? Raise your hand. How many people think it's like 50 or less? How many people think it's like more than 1,000? Okay. Oh, okay. Maybe most of you know. All right. So you got a number in your head? All right. If you said 8,000, you would be correct. And if you said less than 8,000, I would also think that would be really logical, because just 4 years ago, the number was half. Or, oh no, 3 years ago, just 3 years ago, we've doubled the amount of satellites in space. And in the next 7 years, this number is expected to go up by over a factor of 10. This is a lot of data that is coming. This is a lot of different applications. This is a lot of different places that this is going to be used. And so we are going from having a perspective where I can understand what's going around me right now to what's going around me all over the entire surface of the Earth. So many of these satellites are orbiting the whole Earth every single day. And so if we are right now thinking that seeing what's around me right now is already magical in maps, when we get to a point where we can see what's happening, not just today, but every day beforehand for the last 10 years, we throw on a layer of AI. Now we can start making high confidence predictions of how things are going to change in the future. So, and this is, again, all over the surface of the Earth. So I like to think about what this technology is enabling us to do is see everything, everywhere, all at once. And so what we imagine is that the maps of tomorrow are going to be so much more informed that they're going to make these maps that we already think are so magical look as antiquated as MapQuest and Thomas Guide do to us today. How many of you actually know what Thomas Guide is? Okay, some of you. Okay, well, Google. Okay, so what we're getting is we're going beyond our human capacities of knowing what's just around us in our immediate neighborhoods, say, to really understanding in near real time what's happening on a global level, holistically, right? And what are we actually understanding? Well, we usually really think of satellite data as just the wavelengths invisible, like what we can see with our eyes, what we can take a picture of with our phones. But what's amazing about how this technology is moving is that it's not just visible light wavelengths. It's all of the entire electromagnetic spectrum that is telling us different things about what is happening on the surface of the Earth. So yes, visible light tells us about human activity that's going on, but ultraviolet and infrared wavelengths tell us about heat, water vapor, pollution that's happening. We also have other wavelengths that tell us where metal is from space. This can be a proxy for traffic noise. We know salinity, plant health. We know when people are communicating because we can see their wavelengths, their radio waves from space. We can see texture. We can have, and then you layer on all of the other Internet of Things sensors all over the world. You're starting to really understand what's happening in a really new and different way. And this is not new. A lot of industries that you may not have known are already using this technology. For example, you probably don't even think about it, that when you check the weather today to see whether you need to wear socks or not, that was satellite data. That was this infrastructure that powered that. Now farmers are using these images to see if their plants need fertilizing or water. They can see that from space on a large scale. Even archaeologists are using this technology to monitor their archaeology sites and see how they're changing over time and maybe look for places that they can start investigating. So with this, we have so much incredible potential to be able to use this technology, and we've used it really well to make some money, sell things, make our lives more convenient, right? And we're standing up here today because we have some opinions on what it means to use this technology well. And so far, all of the use cases that we've seen are pretty human-centric, right? And we talk about human-centered design, but really, we're just one species on this entire planet, right? And if we were to think about the planet as a really complex, interconnected system filled with nuance, complexities, interdependencies, what if we thought about the planet as a sentient being where we were just one organism on it, one organism that in the microbiome of the planet? And let's give her a name. We'll call her Mother Earth. Okay? If we are but one being on Mother Earth, we want to know, what do we think Mother Earth wants from humans, right? What do we think we can learn about Mother Earth from having this data, from having this whole planet perspective? And how do we meet these needs using this data? Well, from what we've seen, we think Mother Earth would be pretty excited to finally be seen by us. And we put together some thoughts about what she might say to us and what we hear her saying to us now that we have access to being able to talk to her in this new way. So the first thing we think she might say to us is, be humble. You don't know me. There's so many things that we underestimate about how our planet works. And so here's a few examples.
So the first one, as Jenny said, it's a big deal to judge the Earth. We make decisions about what she's up to. When we see a desert, we think of it as dust. I hear of dust storms out here, right? And everyone hates dust storms. And yet this magnificent dust storm is delivering fertilizer, phosphorus, that's needed to enable the Amazon basin to become the Amazon rainforest. Not only that, but when we see hurricanes or natural disasters, we panic. And so for an example of a volcanic eruption, many people freak out. And she might be saying, hey, take a look at what I'm giving you. Just hold on a second. And so in the case of this eruption, you may not realize she's actually pulling from deep within to deliver tons of water, 160,000 tons of water vapor to the surface of the earth. Not only that, she's also bringing fertile soil filled with magnesium and potassium and phosphorus. And when she goes dormant with these volcanoes, we use them. We use them to recover critical minerals that we need to power our cars. We also pull from them gold and silver. Not only that, but she also provides geothermal power sources with those volcanoes. The next one is a place that is really funny to me. I think she says to us sometimes, "You think you know my boundaries. You put boundaries on me. I don't follow your boundaries." And so this is about a wolf named Pluie. People in Alberta, Canada, put an RFID tag on her and a GPS tracker. And they were shocked to find out that Pluie actually traveled 1,000 miles in 9 months. They thought that her pack just lived in Alberta, Canada. They had no idea that they roamed over countries across multiple provinces and states. And so out of this, it actually allowed us to make the connected thoroughfare for wolves. And so there's a lot to learn from where we think our boundaries are and to maybe reconsider them on occasion.
So as we use this data and learn more things about the Earth, we think there's a really critical role for creatives and designers. We can help Mother Earth and tell the story of all these things, these new connections that we're seeing across ecosystems. And these inevitably will surprise and educate people about how our Earth is changing and how it works. And you don't have to be a NASA engineer to do this kind of work. This is one example of an Instagram account that opened in 2013, where someone who was really enthusiastic about satellite imagery just posted pictures about what's going on the Earth. It's called Daily Overview. And really the goal was to really use these images to help people learn about how interconnected and beautiful our Earth is. The next thing we think the Earth might be saying to us is, hey, can you pay attention? Maybe I'm not using the same language as you to say it. So in this case, this is a bird called the Arctic tern. And this bird flies from the North Pole to the South Pole every single year. And we have learned through this technology that its migration patterns are affected by the health of the Earth. And so when the Earth is healthy, the migration patterns go well. And when things go awry, it affects how they migrate across the Earth.
So she might ask us to please pay attention to her sensors. Did you know that in North America, there are 300 species of bird, each a different type of sensor? And we know birds have been used in the past for sensors. You think of the canary in the coal mine. We should probably advance just a little. On your left, you see the Rossby waves. Rossby waves are really fantastic waves that show quite a disruption you see in the red in the middle. And what's going on is that from the poles, the top and the bottom, you're pulling cold air to the midline, to the tropics. And at the same time, the tropics are pushing their air to the poles. And so you get this beautiful disturbance you may be familiar with because it sometimes creates the El Nino effect. And so especially on the eastern United States, those birds they migrate from the south to the north at a certain time of year. But when something is starting, an El Nino in the Pacific, they actually delay their migration. And so these sensors are something we would love to encourage you to continue to design for, to study and see what information we might be able to glean for them, to show to others. The next thing she might say is, maybe you can see yourselves just a little better. This is an image to show how we're connected and where we're disconnected, to show how much light pollution we emit in the middle of the night, to recognize that we're actually disrupting the migration of the Earth's sensors for us, her birds, who migrate at night. And so as creatives, we encourage you to come up with designs that might show how much light pollution you're wasting at night, or designs to show how we might redirect that light to where it's needed for us humans. And we might hear her say, please let me help you. These trees sometimes experience great stress. So trees, when they're healthy, you probably know of their xylem and phloem, they pull up water from the earth. But when they're unhealthy, they stop doing that. When they're healthy, that xylem and phloem, the water vapor that they pull up, actually is released into the atmosphere. And we can see that from space. We can see the health of our trees and their stress before any human eye could ever pick it up. And it is critical to preserve the health of our trees because they're providing an ability to encapsulate toxins, to pull in our carbon dioxide and provide back oxygen and water vapor.
So with this, we think designers and creatives have a really great role to play in helping people recognize these unusual indicators of planetary health. And we can help people listen to them and help us respond. So one example of how we've designed things to help people respond, this is the sea level rise viewer created by NOAA. And this is a sort of interactive calculator that shows how your neighborhood is going to be affected as sea level rises. And if you've been following the Greenland ice sheet, you know that some things are going to be different. And so this is a really beautifully designed way to help people understand how our Earth is changing in a simple way and make it relevant to them. So the third thing we wanted to say, Mother Earth is saying, is, hey, get your act together. We know she's been through at least 5 major mass extinctions. She's very patient, but we still think with how humans are acting, the planet might be a little bit annoyed with us.
She might be saying, could you please take a look at the mess you're creating and consider cleaning it up? You may not be aware, but the amount of plastic that is in the oceans in some places outweighs the amount of plankton 6-to-1. This is absolutely true in the area known as the Pacific Garbage Patch. NASA has actually named part of our ocean the Garbage Patch. That tells us something. It's something I didn't know until I took a look at it. And so it's a call to creatives and designers to come up with ways to communicate the status of the amount of trash and litter we are providing and leaving in our oceans. And then she might say, could you please act a little faster? Could you please know what you're up to? I don't know if you know what happened with the Suez Canal incident, but one of our container ships got stuck. And it's because of Earth observation data that we could see the traffic jam of 350 cargo vessels waiting for over a week to go through the Suez Canal. And because NASA also had additional sensors in space collecting, we could see that the amount of sulfur dioxide produced was 6 times the normal amount. And so if there were a way to create indicators and warnings that could be communicated to mariners about when there might be a traffic jam so that they could divert, and to notify local populations that the amount of sulfur dioxide in their area, their weather, is greatly impacted and they should stay inside. These are things you can do to help communicate the state of our world. The second piece about cargo containers that you may not realize is that 1,000 of them fall into our oceans every single year. And some of them catch fire. from lithium-ion batteries. So thank you, whoever suggested an alternate fuel. In addition, when they fall, sometimes they burst, and the plastic that comes out adds to our garbage patch, adds to our plastic plankton problem. Not only that, it turns out that the tires on the cars that we drive produce microplastics, apparently more than half of the microplastics in the ocean, that are the right size for our plankton to consume. And so again, if there is a way for designers to think of how to keep that plastic inside your containers together when they burst, or to notify the owners of that product so they know where to go pick it up, maybe with a GPS tracker, before it becomes permanent waste in our oceans. That would be awesome. And then she might say, could you please help me heal? I love that you take from me, but please give back. This is a picture of an open pit mine. There are 2 in California. There are many in the United States. Open pit mines have been a wonderful opportunity for us to recover critical resources from this land. But it's also an opportunity with Earth observation to appreciate the amount of damage we've inflicted on her surface. And so there is an opportunity to use a brilliant type of imager called LiDAR that allows us to pinpoint where exactly to do our excavation so that we don't need to excavate all around her. And I would love to see creatives and designers putting forward ideas about how to fix her topology, how to heal it, how to give back and say thank you for what we've taken from her.
So with this, you can hear there are so many opportunities for design to make this better, right? We can design better alternatives. And when there isn't an alternative, we can design better workarounds. And like we talked about in the question answer, perhaps even harder than the design that all of us can really think about is helping people adopt these new alternatives that come through. And that's something that creatives are great at. So I know we are art center people, so we all pay bills. This might look kind of familiar to you. This is my gas bill that I got, right? And the gas company has essentially tried to gamify my gas usage by showing me how my gas is going, comparing me to others in my neighborhood. And this is a way that they're trying to influence me to be a little more conservative for the earth, right? Or conserve more for the earth. And we wonder, what does this look like if this is not about gas usage, but about the amount of microplastics that I'm contributing to the earth, or the amount of light pollution my house represents, right? We can do this for all kinds of things that we're learning with geospatial data on a global scale. And then also, this is just for me as an individual. And we know that a lot of problems and pollutions and impact comes from larger scale agencies and corporations, right? So it has not yet been designed something like this for corporations to influence their kind of impact on light pollution, plastics, and so on, right? That all needs to be thought about and designed as we learn all of these new things about how our Earth is changing.
So the problems. There are always challenges when we develop a new technology. Today, we're going to talk about 2 of them very quickly. The first is the clutter that we're producing. This is NASA's depiction of the 8,000 satellites that currently are in orbit. I want you to take a moment and think about, if you were Earth, it is wonderful to have all of your vitals detected. We love to wear wearables. We love to be monitored. But we don't want to wear these things once they no longer work. And so we encourage people to consider processes that encourage sharing and reuse of the satellite infrastructure that is in our sky. We ask that you might think through how to eliminate these satellites once they have passed their life cycle. But not just that, how might you reharvest the precious materials that we've put up into outer space? Is it possible to make them smaller so that they use fewer resources, so that they use less fuel? And the second is the iniquity. We have this data, not everyone has it. And so how do we make it accessible to all? And so we ask a couple of questions that I want to make sure I share with you. The first question is, how might we encourage designers of this technology to follow the path of companies like organizations like NASA and companies like Cesium? These are unique places that have shared their data. NASA data is readily available. That's where they were pulling on the Instagram page. Cesium has made a point to share all of their Earth observation data with open standards so that it can be used. The second question is that with this satellite data, how might we encourage you and other designers to develop processes that allow broad access to the data while maintaining a level of respect and responsibility in the way that the data is used? The third question is, how do we develop ways so that every citizen on the planet can contribute to this conversation? Those that are human and those that are other species. And the last question we ask is, how do we enable algorithm designers to have a trusted environment where they can actually make corrections to the biases that are in the algorithms that were unforeseen when they started? And one more, how do we build communities of trust so that we can empower our designers, our creators, our builders to fix the problems safely once they see them? So the way forward. It's important to look at the way forward. The most important part first is to know that not everyone thinks of good the way you think of good. And so as a creative and a designer, it's your opportunity to come forward and to push out what good tech in space looks like, and to encourage people of how to regulate it, how to ensure that it is used well.
So we've presented a lot of challenges to you. This is a process that we've developed called Futures Worth Mapping that sort of tries to address and respond to all of these challenges and make sure we're trying to do our best to mitigate some of the harms that have come without these steps. I'll walk through each one of these steps one by one. So the first step is to start somewhere, right? We've seen a bunch of places that could use our attention. Start researching this, understanding a topic, whether it's wolf migration, microplastics, or open pit mines, right? And from there, the second step is to start envisioning scenarios. And I love this audience because there's not too much that you don't already know about how to do this. But we put here baseline scenarios, first order and second order possibilities. So the goal here is really to think about the range of what might happen in the very best case, in the very worst case, and everything in between, so that we can really try and prepare for what we could potentially anticipate, design for that, and then design things to nudge the future towards what we want it to be. And remember, so for step 3, it's really thinking about the data that we have access to be able to indicate which future scenario we're moving towards and to see how we're tracking. And from here, once we have the data and what we want to track and what we want to use to influence our goals, then we get to the fun part. That's designing. We've peppered our talk with so many design ideas that respond to these challenges that we're facing. And this can be something as tangible as a new kind of software that looks at tree health, to a journey, to something really big and broad, which is, what do we want the world to feel like in 5 years? And all of these can really affect change in this rapidly growing industry. We also may really love our ideas, but we want to really be humble about how we use it and make sure we go to the communities that would be using this and be affected by it and say, how could we make this better? And if and probably when we fail, how do you want us to respond? What do you want to see happening? And from there, we're not quite done yet. We want to look at the whole scenario of the whole system of our solution. We want to look at people, of course, but we also want to consider Plui and all the other non-human life on this earth, the ecosystems that surround them, and any assets that are being moved around. So if money or influence or power or resources are happening, we want to know how that works to affect our solution. And then we want to make sure on these green questions that we're not screwing anybody over in a way that we didn't think of. And then finally, act, right? Like this, if you're a techie, all of it's out there. There's so much open source data that you can download. These platforms to work with this data are free. The coding language is open source. You can go out and learn it. And if you're like me, not a techie, then there's still so many things you can do. You can design a UI, you can post all of your things. If you're not cool with something, you can write an open letter to the industry, have a manifesto about what you think is right and wrong for how this data can be used. We think that this is a space that involves a lot of people, and we need all of these voices because it's really affecting all of us. And so when we follow all of these steps, we feel that we can address a lot of these challenges and create a future worth mapping for all of us. And so the one thing, if there's one thing I want you all to know, it's that this future is here. Whether you like it or not, you are part of this geospatial technology. So we want to encourage you to don't just stand there. Like, be aware of what's going on, how this technology is moving, and make it your own. Do something, make it your own so that it becomes our own, and not just for people, but for the whole earth altogether. So thank you so much for having us.